Titanium is stronger than steel, lighter than aluminum, and survives conditions that destroy almost every other metal. So why isn't everything made from titanium? Because making it is shockingly difficult. Titanium sounds futuristic, and for decades it was treated that way. It's used in aircraft, spacecraft, medical implants. Yet most industries avoided it. In this video, we'll explain how titanium is actually made, why it's so hard to produce, and why that's finally starting to change. Titanium has a rare combination of properties. It is as strong as steel, much lighter, extremely resistant to corrosion. Salt water doesn't damage it. Heat barely weakens it. And the human body accepts it. That's why it's used where failure is not an option. But these same traits make titanium difficult to work with. Here's the surprising part. Titanium is not rare. It's one of the most abundant elements in Earth's crust. The problem is, titanium is always bonded tightly to oxygen. Breaking that bond requires extreme heat, careful chemistry, and oxygen-free environments. This is where titanium becomes complicated. Producing titanium is nothing like making steel. First, titanium-rich minerals are mined. Then, they're chemically processed to remove oxygen. Instead of liquid metal, the result is a rough, porous material called titanium sponge. That sponge is then melted in controlled chambers, refined and shaped into usable metal. One small mistake, even tiny oxygen exposure, can ruin the entire batch. That's why titanium production is slow, expensive, and rare. Titanium isn't expensive because it's scarce. It's expensive because it demands precision. The process requires high-energy, special equipment, strict contamination control. For years, this limited titanium to only the most critical applications. But that's changing. New manufacturing methods are making titanium easier to shape, cheaper to produce, more accessible. At the same time, modern technology needs lighter materials, stronger structures, longer lifespans. Titanium meets all three. That's why it's moving beyond aerospace and medicine into transportation, energy, and future technology. Titanium isn't the metal of the future because it's rare. It's the metal of the future because it solves problems other materials can't. For decades, complexity held it back.